Welcome back. As we are discussing the art of ensuring integrity, in that we'll try to discuss the certificates, the basics of digital certificates, and what is the digital certificates. So, in the basic, a digital certificate is equivalent to an electronic passport. So they enable users, hosts, and organizations to exchange information securely over the internet. Specifically, a digital certificate authenticates and verifies that users sending a message are who they claim to be. So, digital certificates can also provide confidentiality for receiver with the means to encrypt a reply. So, digital certificates are similar to physical certificates. For example, the paper based, in this example, you can see the physical CCNA security certificate and the same digital certificate information. So, as said, digital certificates are similar to your physical certificates. So, for example, the paper based Cisco Certified Network Associate Certificate, here it is given that who issued. This certificate is issued to Bob Smith, and this certificate issued by a certificate authority, CA, and its validation date. What is the validity of that? The same thing here in digital certificate, you find it identifies the individual, the certificate authority who authorized this certificate, and for how long this certificate is valid. So you can notice how this digital certificate here is. It is issued to the Adobe Systems Incorporated and issued by the symmetric class 3 extended validation code signing by the certificate authority and its validity date. So in this figure you can see the identified similar elements: issued, issued by, and valid from, similar to your physical certificate. So this is what the digital certificate is. So using this digital certificates, or how it is going to be used, so refer to this figure in the step by step one, from step 1, step 2, step 3, and so on, so up to step 6. So this, by referring to this figure to help understand how digital certificates are used to authenticate a person or entity. In this scenario, Bob is purchasing an online item from Alice website. So Bob's browser will use Alice digital certificate to ensure he is actually shopping on Alice website and to secure traffic between Bob and Alice website. So in the step 1, Bob decides to buy something on Alice website and clicks on proceed to checkout. So his browser initiates a secure connection with Alice web server and displays a lock icon in the security status bar in the browser. The second step, Alice web server receives the request and replies by sending its digital certificate containing the web server public key and other information to Bob's web browser. this digital certificate will be given. In the third step, Bob's browser checks the digital certificate against a stored certificate and confirms that he is indeed connected to Alice web server. So only trusted certificate permits the transaction to go forward. So if the certificate is not valid, then communication fails in this three handshaking process. If it is matching, in the fourth step, Bob's web browser creates a unique session key that will be used for securing the communication, that session key. The fourth step. In the fifth step, Bob's browser encrypts the session key using Alice public key and sends it to the Alice web server. In the sixth step, Alice web server receives the encrypted message from Bob's browser and it uses its private key to decrypt the message and discover the session key. So further, in future exchange between the web server and browser will now use the same session key to encrypt the data. This is how the digital certificate is using for web applications. So what is a certificate authority in that? So we have seen the digital certificate which is issued by who. So the issued by is your certificate authority. So what is a certificate authority then? So to understand this, please look at this figure. On the internet, continually exchanging identification between all parties would be impractical. So therefore, individuals agree to accept the word of a neutral third party. So presumable the third party does an in-depth investigation prior to the issuance of credentials. After this in-depth investigation, the third party issues credentials that are difficult to forge. So from that point forward, all individuals who trust the third party simply accept the credentials that the third party issues. So, for example, in this figure, Alice applies for a driver's license. In this process, she submits evidence of her identity, such as birth certificate, picture ID, and more to a government license bureau in this case. So the bureau validates Alice's identity and permits Alice to complete a driver's examination in this case. Upon successful completion, the licensing bureau issues Alice a driver license. So she receives her driver's license after her identity is proven. So later, Alice needs to cash a check at the bank when it goes to a bank. Upon presenting the check to the bank teller asks her for ID. The bank, because it trusts the government licensing bureau, verifies her identity and cashes the check. So, a certificate authority functions the same as the licensing bureau here. The CA issues digital certificates that authenticate the identity of organizations and users. So these certificates also sign messages to ensure that no one tampered with the messages. So this is the the certificate authority. So let us see what is inside the digital certificate now. So you can see in the figure, as long as digital certificate follows a standard structure, any entity can read and understand it regardless of the issuer. So inside a digital certificate, the standard, that is X509, is a standard for a public key infrastructure to manage digital certificates. The X509 is used. So, public key infrastructure PKI is the policies, roles, and procedures required to create, manage, distribute, use, store, and revoke digital certificates. The X509 standard specifies that digital certificate contain a standard information. So as shown in this figure, one is you find the version. So the version of this digital certificate is X509. And second is the serial number. A unique identity, this serial number uniquely identifies the certificate. Then the certificate algorithm identifier, another standard. So the names of the public key algorithm used by the CA for digital certificate to sign the digital certificate. Then the issuer name, who is issuing the certificate authority name, that identify the certificate authority. And then the validity period, that contains a start and expiration date for which a digital certificate is valid. Then subject name, the owner of the digital certificate. And the subject public key, the owner's public key and public key algorithm, which is used for this digital certificate. Then the issuer unique identifier, that is uniquely identifies the issuer, that certificate authority of the digital certificate. And the subject unique identifier, it may be organization or any individuals, that uniquely identifies the owner of the digital certificate. And the extensions, that is the additional information pertaining to use of the certificate, for what purpose it is going to be used. And finally, the CS digital signature. So in CS digital signature means the digital signature made with the CS private key using the algorithm specified in the certificate algorithm identifier field. This field. So this is what inside the digital certificates. So then, in constructing this digital certificate, it follows this X509 standard. That standard follows these version number, so and so, until it reaches to your digital signature. Then once digital certificate is constructed, it on receiver side it must be go through the validation process. So what is the validation process then? So we'll see the validation process. So browsers and applications perform a validation check before they trust a certificate to ensure they are valid. So the three processes included this validation process. One, certificate discovery validates the certification path by checking each certificate starting at the beginning with the root of certificate authorities, that CS certificate. Then the path validation selects a certificate of issuing certificate authority or issuing CA for each certificate in the chain, and revocation path that determines whether the certificate was revoked and why. So these are the three processes that include the validation process. So now let us see the certificate path. So in the certificate path, as shown in this figure, an individual gets a certificate for a public key from a commercial certificate authority, from this commercial certificate authority. The certificate belongs to a chain of certificates called the chain of trust. So it is going from owner to issuer, issuer to the root, and from root to issuer, issuer to your owner. The number of certificates in the chain depends on the hierarchical structure of the certificate authority. So in this figure, you can see a certificate chain for a two-tier CAs. There is an offline root CA here, the root certificate authority, and an online subordinate certificate authority. So the reason for this two-tier structure is that X509 signing allows for easier recovery in the event of a compromise. If there is an offline CA, it can sign the new online CA certificate. If there is not an offline CA, a user has to install a new root CA certificate on every client machine, phone, or tablet. So this is the certificate path. So owner will send a request that gets certificate to the online issuer. Further, online issuer forwards that request, get certificate request to the offline CA. Then offline CA replied for the verifying signature to your online server, and from there it will be verified. Send the verified signature to your owner. So let us see this this certificate part. So in the next, we'll try to discuss the database integrity enforce for the art of ensuring the data in the next video session.